Hi, good evening, everyone. Good evening, dear students.
Yeah, good evening, everyone. So you can see only 62 students are present in the session. So please let your friends also join in the session. Then we're going to start. Okay. So please wait for a few minutes. If you have any queries, you can ask in the Q&A. Okay. So before starting the session, please let your friends also know that session has started. Okay. So let them also join in the session. So meanwhile, if you have any doubts, you can ask in the Q&A regarding the previous sessions. Okay. Good evening, everyone. If your friends have not joined the session, please let them also know that session has started. Okay, within few minutes we will go into start the session. Okay. Yeah. Good evening, everyone. So, shall we start the session? Can I get a thumbs up symbol? If you want to start me to start, please give a thumbs up symbol so we can move further. Okay. Yeah. Thank you. So let me tell you what the session is really going to give you. Okay. So, but I will explain it in a very simple way. Okay. So, what are the topic we're going to discuss? Okay. By the end of today, you won't just know some new AI terms. You will actually understand how modern AI system behaves when they work on their own. Okay. One of the biggest thing you will understand is why handling error is such a serious issue in AI. When humans make mistakes, usually only one person is affected. But when AI makes a mistake, that makes mistake can affect thousands of or even millions of people at the same time, right? So that's why error handling become very important in agentic AI. Okay, can you hear me? Is my voice is audible, guys? Please let me know in the call in the Q&A. Yeah, fine. So we are discussing about error handling in agentic AI. Okay, so this is our today's topic, right? Yeah. So you will also understand how AI system correct themselves without a human constantly watching them. Think about how you notice your own mistakes while solving a problem and then fix them. AI systems are now being designed to do something similar. We will talk about how AI checks its own actions and changes direction when something goes wrong. So another important idea you will learn is reasoning loops. This is how AI keeps thinking again and again instead of making one decision and stopping. Finally, you will get a clear picture of how real AI agents are built using platforms like IBM Watson.ai. You don't need to worry about coding, just focus on understanding the ideas, because once the ideas are clear, everything else become easier, right? Yeah, sure. Is my voice is audible? Please let me know in the Q&A. Is my voice is audible or not? Yeah, thank you for replying. So let's start with the next slide. Now let's talk about why error handling really matters in agentic AI. Okay, so when we say an AI system is agentic, it means that the system allowed to work on its own without our interaction, checking every small step, right? This is very powerful, but it is also risky. Imagine an AI system that is approving loans, driving license, driving vehicles, or deciding what news content people see. If such a system makes a mistake and doesn't realize it, the impact can be serious, right? Yes or no? One important thing to understand is that errors in AI doesn't stay small. One wrong decision can lead to another wrong action, and that can spread across different parts of the system. Think about Google Maps giving a wrong route. One small mistake can send thousands of people into traffic at the same time. In the systems like healthcare or finance, a small error can lead to a big real world problems. That is why reliable AI systems must be able to detect errors, handle them properly, and overcome from them. Intelligence is not about never making mistakes. Intelligence is about recognizing mistakes and improving after them. An AI system that cannot recover from errors is not truly intelligent. That is why error handling is a core part of agentic AI. Got it? Guys, I want to know whether you are able to understand or not in the Q&A session, or give a thumbs up so that I can understand you are able to follow me. So if I am going very fast, please let me know in the Q&A so I can slow down, or if I am saying slow, please let me know so I can faster my teaching. Okay. If everything is fine, please give a thumbs up symbol so that I can maintain the same rhythm. Okay. You're getting right. Please let me know in the Q&A. So if you are able to understand the concepts, please let me know in the Q&A. Yes. Okay. If you have any doubts, you can ask in the Q&A. Okay. Otherwise, so now we have understand why error handling matters in agentic AI, right? So everyone got the concept why error handling is important in agentic AI, right? So now let's understand the different ways in which AI system can make mistakes, just like us. AI does not always fail in the same way. Sometimes the problem starts right at the input stage. The AI might hear something incorrectly, see something incorrectly, or misunderstanding the data it receives. For example, a voice assistant might misunderstand your command because of background noise. In such cases, the AI is working with wrong information from the start. So whatever it does next is like to be a wrong, right? Yes or no? So if the input is wrong, then the agent will perform wrong steps, right, on the same data. Sometimes the AI understands the input correctly, but still reaches the wrong conclusion. This happens because the reasoning process itself is flawed. It is similar to a student reading a question correctly but replying the wrong formula. There are also planning mistakes where the AI knows what needs to be done but arranges the steps is wrong order. Imagine trying to submit a assessment before writing it. That doesn't make sense. And the AI can make similar mistakes also, right? Finally, there are execution problems. The AI might know exactly what actions to take, but the tool or the system is useful uses fails. Maybe a API is down or a server is unavailable. Understanding these different error types helps us design AI systems that doesn't fail silently but responds intelligently. Got it? So so we have different types here, right? Perception error. So what it means: wrong input interpretation, reasoning error, incorrect conclusions. So we have given a correct input, but we got wrong output at finally, right? Planning error. So invalid task sequences. So we have not arranged the actions in a correct order. Action execution error. So APIs or tools are failing. So what we need to do? Alternative actions must be taken. So these are the four types we are having as errors in agentic AI systems. Got it? Please let me know in the Q&A session if you're clear with the types of errors or not in the Q&A. Guys, till now if you have any doubts, you can ask in the Q&A. If not, please give a thumbs up symbol so that we can move to the next slide. Okay. Yeah. So our next topic is error handling in traditional systems versus agentic AI systems. Right? Can you hear me? Is my voice is audible or not? Please let me know in the Q&A. Yeah, can you hear me, right? Yeah. So in traditional systems, error handling is very basic. When something goes wrong, the system usually stops or shows an error message, right? Doesn't not try to fix the problem by itself. We have to step in, right? We have to solve the problem at that moment. So restart the system or change the code. Errors are treated like the end of the process. In agentic AI systems, errors are treated differently. When something goes wrong, the system does not stop. It detects the error, think about the step what need to do. It tries in different way. It can retry actions, change its plan, or ask for help only if needed. Errors become part of learning, not a dead end. The main difference is simple. Traditional AM systems wait for us to fix the errors. Agentic AI systems try to fix themselves and continue working. Right? This is the difference between traditional systems and agentic AI systems. Got it? I want to know how many of you have understood what is the difference between traditional and agentic AI systems error handlings. Please let me know in the Q&A. Is that clear? I need response from everyone. So I can see around 180 students are there. I'm getting very less responses. So if you are facing any issue, please let me know in the Q&A. So or else you can give a thumbs up. Okay. I want response from everyone. So I'm getting board symbols like thumbs ups. So can I get us some different symbols, emojis? You can see different emojis are there. You can use those also. I want everyone to active in the session, okay? While we are having sessions, okay? So please be active in the session during the session, okay? So if you have any doubts, you can ask in the Q&A, okay? Thank you for responding. Yeah. Yeah, let's go to the next slide, okay? Are you okay? Shall we move to the next slide? Or I want to wait? Yeah, Printy, we will provide the attendance. Don't worry about the attendance, okay? Guys, shall we move to the next slide? Yeah, sure. So now you might be wondering, how does the AI system even know what it has made a mistake, right? Unlike us, AI doesn't feel confusion or doubt. It relies completely on single signals and checks. These checks are built into a system so it can compare that it expected to happen with what actually happened. If there is a big difference between the two, the system understands that something went wrong. For example, imagine AI is trying to book a ticket. If it sends the request and gets a failure message in return, that response itself becomes a signal that the action did not succeed. Right? Similarly, AI systems often use confidence levels. It, if the system is very unsure about its output, that low confidence becomes a warning sign. Rules also play an important role. If an action breaks a rule or policy, the system treats it as an error. Okay, so got it how this agentic AI will identify errors, right? Yes or no? Please let me know in the Q&A. So feedback from a environment is another powerful signal. If the AI takes an action and the situation become worse instead of better, that change tells the system that it decide decisions was wrong. Detecting errors is the first and most important step. Without knowing that something is wrong, an AI system cannot improve or correct itself. So knowing the error is very important for the agent to correct the error itself, right? So let's move to the next slide. So now let's talk about self correction. And I promise this is very easy idea. Self correction simplify means the AI can fix itself its own mistakes. Just like when you write an answer in an exam, realize it's wrong and then correct it, right? The AI does the same thing, okay, but automatically. Imagine you type a word wrong on your phone. Your phone doesn't stop working. It corrects the word and moves on. That is a basic example of self correction. So I hope everyone have faced the same issue, right? When you type, when you searching on a web, so if you search like something wrong, so it won't stop, right? It will give some suggestions. So it's an AI system backend it's running, okay? In agentic AI, this idea is much bigger. The AI looks at what it did, checks the result, and if something didn't work, it changes its decisions. Okay, this is important because we cannot watch AI systems all the time. AI makes thousands of decisions every second. If it had to wait for us to fix every mistake, nothing would work. Self correction allows AI to work smoothly, learn from errors, and improve over time. This is what makes the modern AI systems more reliable and useful. Got it? So, what is self correction? Do you understand or not? Please let me know in the Q&A. Got it right? Guys, I want a response from your side. So, did you got the concept or not? So, what is self correction? Please let me know in the Q&A. Shall we move to the next slide? Or else if you have any doubts, you can ask in the Q&A, okay? I want response from everyone. Please try to be active in the session, okay? Yeah, shall we move to the next slide? Shall we move to the next slide? Yeah. So I want response from everyone so that we can move to the next slide, okay? So we will start next slide, okay? So our next slide is about mechanisms for self-correction, okay? So now let's continue with how AI correct itself in practice, okay? Self-correction doesn't mean the AI keeps doing the same thing again and again blindly. Instead, it first thinks again using new information. It looks at what went wrong, understands the situation better, and then decides what to do next. This is similar to how you solve a questions, right? If your first answer is wrong, you don't repeat the same answer. You rethink the question and try a different approach, right? Sometimes the AI changes its plans completely. Sometimes it tries the same action again, but in safer or more limited way. For example, if an online payment fails, the system might retry once or twice instead of repeating it endlessly. And in some situations, the AI decides the problem is too risky or confusing. In that case, it sends the decision to us, right? This is actually a good thing. Smart systems know their limitations. Just like you ask a teacher or friend when you are unsure, AI should also ask us help when needed. This balance makes AI systems safer and more trustworthy. Guys, please let me know. Is that teaching style is okay for you, or I need to go fast or slower? Please let me know in the Q&A. So if it is okay, so we can continue with the same style, okay? So if you are okay, please join the fire emoji, okay? I want response from everyone, okay? So be active in the session. Yeah, Rohit, okay, I will say first, okay? No worries. Yeah, okay. So let's move to the next slide. So that is about role of feedback in self-correction. Okay. So now let's talk about feedback, which is how AI learns from what it does. Feedback is basically the response the AI gets after taking an action. Okay. Think about how you learn in real life. You try something, you see the results, and then you decide whether to do it again or change your approach. AI learns in a very similar way. Feedback can come from any place. When AI uses a tool and gets a response, that response tells the AI whether the action worked or failed. System records also help the AI understand what happened behind the scenes. Users also give feedback, sometimes directly and sometimes indirectly. For example, if users stop using an app feature, that itself is a kind of a feedback. Even the environment gives feedback. If an AI changes something and the situation improves, that is a positive signal. If things get worse, that is a negative signal. Without feedback, AI would keep repeating mistakes. Feedback helps the AI learn, adjust, and slowly become better at what it does. Okay, so yeah, I will explain with the example also. At the end of the session, we are having practical examples. So I will also explain that practical examples also. Okay, no worries about the examples. Rohit, thank you for your suggestion. Got it right? What is feedback? How it plays a crucial role in agentic AI systems, right? Shall we start the next concept or else I have to wait? Have any doubts? Please let me know in the Q&A. Okay. Please let me know. Shall we move to the next slide or if you have any doubts, you can ask in the Q&A. Okay. If you don't have any doubts, please give a thumbs up symbol so that we can move to the next concept. Okay. Guys, shall we move to the next slide? Yeah, okay. So let's start the next slide. So which is about introduction to reasoning loops, right? So now we are coming to a very important idea called reasoning loops. But don't worry, it's a actually very simple. A reasoning loop is just a cycle where the AI keeps thinking and act again and again instead of stopping after one step. Imagine now how you decide what to eat for dinner. You think about what you want. You choose something, you eat it, right? And then you decide if you liked it or not. Next time you change your choice based on that experience. That is a reasoning loop. Got it? So did you got what is reasoning loop? It's very simple, right? What is the reasoning loop? So based on current situation, so based on our past experience, you will update your plans, right? In AI, the same thing happens. The system thinks about the situation, takes an action, looks at the result, and then thinks again. If the result is good, it continues. If the result is bad, it changes its approach. Earlier, AI systems worked in one time way. They made one decision and stopped. If that decision was wrong, the whole system failed. So reasoning loops make AI flexible. They allow the systems to adjust, improve, and move closer to the goal step by step. This is what makes modern AI feel smarter and more like us. Okay. So let me know how many of you have understood reasoning loops. Please let me know in the Q&A. I want a response from your side. So I think everyone is uh, went to inactive mode, I think. So be active in mode, okay? So I need response from your side. Yeah, sure. I will explain once more, okay? No worries. So what about others? Have you got the concept or not? Please let me know in the Q&A. I think if you are not understood the concept, what is reasoning loop? So I will explain once again. Okay, no worries about that. So if you have any other doubts also, you can mention in the Q&A. Fine. So reasoning loop is a simple idea. It means the AI does nothing, think or act only once. Instead of it keeps repeating the process of everything and acting. Just like us, AI learns from what happens after it takes an action. Okay, so AI learns from what happens after it takes an action. Okay, for example, when you choose a food for dinner, you try something. see if you like it or not, and the next time you decide differently if needed, right? So if you like the food, you can continue with that food for the next time. So if you don't like that, you can choose another way, right? Another food item, right? That is a reasoning loop. In AI, the system first think about the situation, then takes an action, checks the results, and then thinks again. If the result is good, it continues in the same way. If the result is bad, it changes its action. Okay. So older AI system made one decision and stopped. So if the system is failed at once, it will display an error and it stops working. So we have to interact with the system and we have to check what's went wrong and we have to fix it, right? So now agentic AI systems are not like that, right? So it is entirely automated. So if something is failed, it has to fix by itself and continue with the different approaches towards its end goal, right? Got it? So if you have understood, please give a thumbs up. If you have any doubts, please let me know in the Q&A. Yeah, thank you. Thank you for your response. So shall we move to the in-depth of reasoning loop? Guys, I want response from your side. Is it okay? Are you getting the concepts? So please, I'm requesting you to respond with a different symbols so that I can see how many of you are active in the session. Okay. So I want response from your side, from everyone. Okay. Is my voice is audible? Yeah. Okay. So I want response from everyone. I want to know how many of you are active in the session. I can see very less emojis. Yeah. Okay. So shall we continue with the next concept, structure of reasoning loop? Can I get a thumbs up symbol for approval from your side? So someone is sending emojis like biceps. Yeah. So shall we move to the next concept? You're right. So now let's understand what actually happens inside a reasoning loop. Okay. But in every easy way, when an AI system is working, it doesn't just act randomly. First, it looks at its goal and checks whether the goal is still the same. For example, if the goal is to help a user, the AI keeps that in mind all the time. Then it looks at the current situation, it checks what information it has right now and what has changed since the last action. After that, the AI decides what to do next. If something doesn't work earlier, it changes its actions or decisions. Then it performs an action and waits to see what happens. Once the result comes, the AI looks at it carefully. If the result is good, it continues if the in the same direction. If the result is bad, it adjusts the direction. Okay. This process keeps repeating. That is why it is called loop. The AI is always checking, acting, and learning. This structure helps the AI move closer to the goal step by step instead of failing suddenly. Okay, got it? So, what is reasoning loop? You got an idea, right? So, in reasoning loop, the AI is always checking, acting, and learning continuously. Okay, so if something went wrong, it will check the actions and what it has to perform, and then it will tries in a different ways if that action is failed. So if it that action is okay, so it will continue. Okay, got it? Guys, shall we move to the next slide? So our next topic is reasoning loops in agentic AI. So till now we have discussed what is reasoning loops, right? So now we are discussing about reasoning loops inside agentic AI. Okay. So how many of you are interested? Please let me know with your different symbols or with your emotions. Okay. Guys, can I get some different symbols from your side? I can see different types of symbols here. Okay. We are also having ghosts emoji also. Somebody sending egg. Yeah, it's great. Okay, shall we move to the next topic? That is reasoning loops in agentic AI. Okay. Yeah, someone is traveling, I think so. He's sailing flight. Okay, so let's start. Now let's see how reasoning loops work inside agentic AI systems. In modern AI, language models play a big role in helping the system think and understand situations. They help the AI decide what makes sense and what doesn't. But reasoning alone is not enough. The AI also need memory. Memory helps the system remember what happens earlier, what works, and what fails, right? So if doesn't have memory, so how we can it can remember the past actions, whether the actions are failed or succeeded. So depends on that situation, it has to work, right? So for that it has to have memory. Got it? So how we have brain, so the system has to have memory to manage the things. Okay, because the AI remembers past outcomes, it doesn't repeat the same mistakes again and again. It uses that memory to improve future decisions. Planning it another important part. The AI doesn't follow the fixed plan forever. It changes its plans based on new information. It some sometimes unexpected happens, the plan is updated. Okay, so if something is not working, it has to be do it in different ways, right? All these parts work together inside a reasoning loop. This is what allows the AI to behave intelligently over time instead of giving just one answer and stopping. So what the earlier systems has done. Reasoning loops learn AI from simple question answers machine into a system that can continuously improve and adapt. This is why modern AI feels much more powerful and useful than older systems, right? So shall we start the next slide? That is reasoning loop versus one-shot execution. Okay. So you have only few differences, right? Single response, continuous decisions, no revision, self-correcting, stateless, context aware, right? So shall we start with that slide? So now let's compare two different ways AI systems can work, but we will keep it very simple. Some AI systems work in what we call a one-shot way. This means the AI looks at the input, gives one output, and then stops. If the output is wrong, there is no second chance. That means it's wrong only. The system doesn't think again or retry to improve. It just fails. So now think about how we work. If your answer for a question wrong, you don't stop learning forever, right? You look at the mistake, understand what went wrong, and try again. Reasoning loops allows AI to work in this way. Okay. So instead of stopping after one action, the AI keeps checking the improvement. This difference is very important. One shot systems are simple but fails. Reasoning based systems are flexible and strong. They can handle unexpected situations much better. This is why modern AI systems use reasoning loops instead of one time decision. It allows them to grow, adapt, and perform better in real world conditions where everything is not perfect. Right? So there is a simple difference between one shot AI and reasoning loop AI. Okay. Sorry, I was in mute. Can you hear me? Is my voice is audible? Yeah, okay. So, so now let's look at a very simple example of how all this works together in real life. Okay, imagine a system notices that something is not working properly. The first thing is to do is to identify the issue. It tries to understand what exactly went wrong. After that, it thinks the possible solution. This is a similar how we troubleshoot a problem with your phone or with your brain. Okay, right? You don't you don't panic. You first try to understand the issue, right? Once the AI is having the solution in mind, it takes actions. It executes that solution and then waits to see the result. After the action is done, the AI checks what happened. Did the problem get fixed or not? If the result is good, the AI continues. If the result is bad, the AI doesn't give up. Okay, it thinks again and improves the solution. This cycle keeps repeating until the goal is achieved. That is why it is called a loop. The AI keeps learning and improving step by step, just like us when we solve a problem, right? I hope everyone is clear with the reasoning loop, right? If you have any doubts regarding reasoning loop, please let me know in the Q&A. If you are clear, please give a thumbs up symbol so that I can understand you are getting the concept. Okay. So reasoning loop is very simple. So if you are getting any problem, so we will see the current situation. So we try a solution. If it is works, we will move further. If it doesn't work, we will try in a different approach. So that's what reasoning loop is. So I think everyone is familiar with the loops in Python or Java, right? In coding language. So iterations, right? We'll call. So we give a condition and we will run repeating the same thing again and again, right? So if the condition is true, then we will stop the looping. So in the same similar way, the reasoning loop works in agentic AI. Okay. If something is went wrong, it will check for the better options, and if that option is okay, it will continue, or else it will check for another option. Okay, got it? If you are clear, please mention clear in the Q&A session. Okay, if you have any doubts, please let me know in the Q&A itself. Okay. Guys, I want response from your side. Is that clear? What is reasoning loop and how we can implement that reasoning loop in our agentic AI? Please mention in the Q&A. If you have any doubts, please let me know in the Q&A. If you don't have any doubts, please let me know with your thumbs up symbol so that we can move to the another slide. Okay. Can I get a fire emoji from you? If if the concept is clear, please give a fire emoji. Okay. So if you have any doubts, please let me know in the Q&A so that we can resolve that. Okay. So if you are clear, please send a fire emoji. Okay. I want from everyone. Okay. So if you are not clear, please let me know in the Q&A. Okay. So if you are clear, please give an emoji of fire. Okay. Everyone is sending slow by slow. May I get at one time so I can see fire symbols on enter screen at once. I think everyone is clear with the concept, right? What is reasoning looping and how it is implemented in agentic AI, right? So I will say one, two, three. You can give a fire emoji so that we can move to the next slide, right? One, two, three. So please, I want everyone to give a fire emoji so that I can see the fire emoji on the screen. Okay. So then we can move to the next slide. Okay. Okay. I got very few. Okay. Fine. That's fine. So be active in the session. Okay. So don't be in the deactive mode. Be in active mode. Okay. So the next topic is error handling plus reasoning loop together. So how these two works together. Okay. So we understand how these two things works together. Okay. So now let's understand the strong connection between errors and reasoning loops. When an AI system makes a mistake, that mistake becomes a signal for system to think again. Okay. Instead of stopping or crashing, the AI uses the error as a feedback. So it uses error as a feedback. It asks itself what went wrong and what can be done differently next time. So to get the better output. This is where reasoning loop become very important. Without a reasoning loop, an AI system might detect an error but not know what to do next. So with a reasoning loop, the AI system automatically start re-evaluating its decisions. It changes its plans, adjusts its actions, and tries again in the smarter way. So over the time, this makes the AI more reliable. The system doesn't repeat the same mistakes again and again. It solves slowly, becomes better at handling different situations. So error handlings without reasoning loops is incomplete because detection alone is not enough, right? The system must also know how to respond and improve together. Error handling and reasoning loop help create AI systems that are strong, stable, and trustworthy. Okay. So for a better AI, we need error handling with reasoning loop together. Okay. So to resolve a real world problem, so we need these two things to be together. Okay. So error handling without reasoning loop is incomplete, right? So that's why we need two things together to get a better AI system. Okay. So shall we move to the next slide? Let me know how many of you want break right now, or if you want break right now, please mention Q in Q&A break, or else we can continue with the concepts. Okay. So if you need break, please mention break. Okay. So that based on your voting, I can give the break. Okay. So very few have given responses. That means no one wants break, right? Is that true? So if you want break, I want a teacup as a symbol. Okay. So for I want reply as a teacup. So we can give a tea break or some short break. Okay. Okay. Let's take 10 minutes break and then we will continue with the next topics. Okay. So meanwhile, if you have any doubts, please mention in the Q&A. Okay. Yeah, hello, hi. Did you add your break, right? Shall we start the next slide? Is that okay? Guys, I need response from your side. Is that your break is done? So I have given 10 minutes, right? So we have more 5 slides we need to complete, okay? So we have to cover those topics also. So at the end of the session, we are having quiz, practical examples, okay? And we also provide attendance sheet, okay? Fine. Shall we start? So, so by seeing the title, what you have got, so human in the loop for critical errors. So, what did you understand by this line? So, if you have any idea about that, please let me know in the Q&A. Okay. So, if you don't know anything, so it's fine. It's well and good. Okay. So, we will discuss about that. So, if you have any answer, please provide in the Q&A. Okay. Okay, fine. I have not received any answers. Okay, so it's good. So starting anything from scratch is good thing, right? So without knowing some anything about that, it's better only. So we can learn from scratch. Okay. So now let's talk about something very important. So which is known when AI should stop and involve humans. Okay. Even the smarter AI systems should not make every decision on their own. There are situations where the risk is high, the outcome is uncertain, or important rules and policies are involved. In such cases, it is safer for the AI to pause and ask for human approval, right? So if we are dealing with a medical emergency, okay, so we are using a agent. So if that agent is not working well, so that leads to a critical situation, right? So before going for actions, it has to ask for a doctor so that he can confirm that, so he can do it or he can stop at that moment, right? So in some fields, the agents has to be worked with the help of our interactions, okay? So blindly depending on AI, it's not good, right? Because say small thing can change entire thing, right? So that's why we have to be in the loop, okay? Think about how you behave in a real life. If you are making a small decision, you decide on your own. But if the decision is serious, like signing a legal document or making a big financial choice, you ask someone who is having experienced. Okay, so AI should behave in the same way. When the situation is risky or unclear, it should escalate the decision. This human oversight helps the build trust and AI systems. People feel more comfortable knowing that important decisions are not fully controlled by machines. AI is meant to assist humans, not replace responsibility, right? A good agentic AI system knows its limitations and responses, right? Respects our decisions. This balance between automation and human control is what makes AI safe and reliable, right? Do you think the same? Please let me know in the Q&A. So blindly depending on an agent is not good, and when there is a situation like risky or especially critical situations, so we have to be in the control, right? Yes or no? So if, for example, if you take a patient in the hospital, so if it is a heart operation, okay, so agent is working on that. So if it has no clarity what it is doing, it has to ask doctor, right? So if it is not asking, there might be a bad situation, right? So that's why we have to be in control when the agent is don't know what to do. So if it is doesn't know and it is having confusions, so it has to ask our decisions to make sure that the situation is going smoother. Okay, so that's what about human in the loop for critical errors. Okay, so when agents escalate high risk decisions, uncertain outcomes, policy violations, so human oversight ensures safety and trust, right? Got it? So shall we move to the next slide? The concepts are very simple, right? I think everyone is able to understand the concepts, right? So what is human in the loop? So if you have any clarity, please mention clear, or if you have any doubts, please mention what your doubt, okay, in the Q&A. So human in the loop means, so when there is a critical situation or high risky uh, decisions we have to take, so we have to be in the control, right? So entirely depending on agent is not a good choice. So that's why we have to be in the control so that we can work smoother. Okay, shall we move to the next slide? We will share the attendance at the end of the session. Okay, so don't worry about the attendance, we will provide the link. Okay, yeah, sure. So let's move to the next topic. So our next topic is overview of hands-on agent development. Okay, so let's discuss about this in simple. Okay, now let's talk about how these intelligent agents are actually built. Okay, creating an AI agent is not about writing random code or giving random instructions. It starts with clear decisions what the agent's goal is. If the goal is not clear, the agent will behave in confusing ways. Once the goal is defined, the next step is to design how the agent will think and make decisions. So this includes deciding how the reasoning loop will work and how the agent will respond when something went wrong. The agent also needs access to tools and memory. Okay, so tools helps the agent perform actions like calling the API or fetching information, right? Memory helps the agent remember past actions and results so it can improve by actions, right? So error handling is added to make sure that agent doesn't fail silently. Okay, instead it should notice mistakes and correct itself. All these parts together create a useful and reliable agent. Good agents are carefully designed, tested, and improved over time. Okay, so they are not built in one day, just like skills are not learned overnight. Right? Got it? Guys, don't worry about attendance sheet. We will share at the end of the session. Okay. So shall we move to the next one? So you got the idea, right? How the agents are built. So first we have to define goal. So then we have to decide reasoning plan. Then we have to integrate the tools and memory. So tools are used for actions and memory is you use it for remembering the past actions, how they are done, whether it is succeeded or not, and then implementing error handlings. So how these errors can be handled, right? So now let's talk about a real platform that helps build these kind of AI agents called IBM Watson X.ai. Okay, this is a platform is designed to make it easier to create AI systems that are not only powerful but also safe and well controlled. Instead of building everything from scratch, developers can use this platform to design how the AI think, reasons, and responses. So IBM Watson X.ai supports large language models that helps with understanding and reasoning. It also provides features that helps manages prompts, workflows, and rules. Okay, this is important because when AI systems are used in companies, they must follow certain policies and guidelines. The platform helps ensure that AI decides transparent and controlled. For larger organizations, safety and trust matters a lot, right? So they need AI systems that can explain what they are doing and why. Platforms like IBM Watson.ai helps this possible. They allows teams to focus on designing good behavior instead of worrying about low-level technical details. This makes building agentic AI more practical and reliable in real world environment. Okay. So next move to the next slide, agent workflow in IBM Watson.ai. Okay, conceptually. So we are not going to be uh, doing practically. This is okay. Don't worry. Just understand the concept. Okay. We can do it on later. Okay. So now let's look at how a typical agent workflow looks when using a platform like IBM Watson.ai. Okay, the process usually starts with deciding how the agent should understand instructions. This is done by carefully designing the prompts so the AI knows what it is supposed to do and how it should behave. Once the AI understands it rule, tools are connected so it can actually perform actions like retrieving information or interacting with other systems. Memory is also an important part of workflow, right? So because it will store the previous actions details, right? The agents needs to remember what happens earlier so it make better decisions in the future, right? That's what memory will do, right? So after the agent perform actions, its performance is evaluated. Developers checks whether the agent is behaving correctly and safely. If something is not working well, changes are made. That's what exactly, right? So this process repeated again and again. So each cycle improves the agent slightly. Though, so platforms like IBM Watson AI make this workflow easier by providing built-in support for testing, evolutions, and iterations. This process helps teams to build strong AI agents without unnecessary complexities. Okay, so that's why we use IBM Watson IBM Watson X.AI platform. So we came at end of the PPT. Okay, so now we are coming closer to the end. So let's bring everything together. So one of the biggest idea you should remember is that error handling is not optional in agentic AI. Okay, when AI systems works on their own, they must be able to notice when something goes wrong and respond properly. Without this ability, AI systems become dangerous and unreliable. Okay, so correlation, sorry, self correction is what allows AI to work independently. It helps the system fix mistakes, right? So improve decisions and avoid repeating the same errors again and again. So reasoning loop supports this process by allowing the AI to keep thinking and adjusting the instead of stopping after one action. So together these ideas makes AI systems more stable and trustworthy, right? So platforms like IBM Watson IBM Watson X.AI helps bringing all of this together in real world applications. They provide tools for building, testing, and controlling AI agents at scale. Strong AI systems are not perfect, but they are designed to learn and improve. That is what makes them useful in real world situations, right? So guys, if you have any doubts, please let me know. So we'll conduct the quiz meanwhile, okay? So guys, we'll share the attendance sheet shortly. Okay, don't worry about the attendance form. Okay. Guys, please everyone has to attend the quiz. Okay, so we have shared the screen, right? Please join as soon as possible. Okay, so everyone has to participate in the quiz. Okay. Guys, as soon as possible, please join in the quiz. Okay, so we have left with very few minutes, so please join in the quiz, and then we're going to start. Okay, please join as soon as possible. Okay, guys, those who have not joined it, please join in the quiz. So then we're going to start the quiz. Okay, so I can see 209 students are there, and I can see only 54 participants in the quiz. Please join as soon as possible. Okay.
Students, kindly join the quiz, and the quiz code is in the Q&A and the QR is on the screen. Join the quiz immediately so that we can start the quiz. Hurry up.
Guys, please hurry up. Please join the quiz as soon as possible. Okay. So we are left with very few minutes, right? So please try to understand the situation and join in the quiz as soon as possible. Okay. So we are sharing the attendance sheet also. Don't worry about attendance form. Okay. So we have shared that once again. And please join as soon as possible. The quiz is waiting for you. Okay. So I can say only 72 participants are there. So we need more participants to start the quiz. Okay, please don't neglect the quiz. So join as soon as possible. Okay, so everyone is waiting for you. Hurry up, guys. Guys, those who have attended the quiz, please let your friends also join. So please inform them to join the quiz. So it is also important. So we will separate marks for quiz also. So please let them join as soon as possible. Okay. Guys, we'll wait for 1 more minute. So please let your friends also join in the quiz. Okay. So please inform if they are not joined yet. So please tell them to join in the quiz. Okay. Guys, please join in the quiz as soon as possible. Okay? Within 1 minute, I'm going to start. So then you cannot join again, right? So please understand. So join in the quiz as soon as possible. Okay. So I will start at 6. Okay. And meanwhile, don't leave the session. Okay. So we have a practical example. So we have to discuss. Okay. So I will explain in within 5 minutes. Okay. Don't worry about that. So meanwhile, complete the quiz as soon as possible. Okay. Yeah, guys, I am going to start the quiz. Okay, so do it your best. Okay, guys, I'm creating a poll. So if you are done with the quiz, please update the poll. If you are done the quiz, please update the quiz.
Students, the attendance link will be accepted only before 8 p.m. That is why we shared the form before 8 p.m. only. And don't worry that your attendance get marked when, like, if you are in the session for the whole time. Thank you for that. And kindly don't leave the session.
Guys, please. How many of you have example how you can see the so please give it example so give it example. I will give 1 more minute to complete this. So then we can go with the next minute to do it. Complete the quiz, not complete it. Okay, guys, and this it's move to so how many of you are interested to see first and second and third positions? So if you want to see, please let me know. We can see the dashboard of our top three. Okay. So if you don't want, we can go with the practical lab. Okay. So I'm starting with practical example. Okay. So you can see I have written some code, right? So don't worry about that. I will explain one by one how it works like. Okay. So agent will work. So we can demonstrate with this example. Okay. So let's start with the first cell. So I have created a simple example. So I am giving a agent two values. Okay. One number is 10 and the other is divider is 0, right? So I already know this will cause an error, right? So if you are aware of zero division error, so you might know this problem, right? So but the agent doesn't know that yet. This is a similar to real life. Okay, so where an AI system starts with some input that looks okay but actually has an issue. So the last line just tells us that the agent is ready to start its work. Nothing has failed yet. This is just a starting situation. Okay, so let's run it. So you can see, so agent is ready to start work, right? So the next cell is, so you can see we have 3 lines of code, right? So now the agent is trying to do its task. So in the first cell, the agent is ready. So in second, it is trying to start the task. Okay. So before actually doing the division, it checks something very important. It checks whether the divider is 0. This is called error detection. The agent realizes that dividing by 0 is not allowed, right? So instead of crashing or giving a wrong answer, it clearly says that there is a problem. This step is very important because if the agent does not detect the error here, the whole system will break. In real AI systems, this kind of checking happens all the time before taking an action. Okay, so you can see that after executing that, you can find that agent is trying to divide the number. Error detected, cannot divide by 0, right? So in the third cell, you can see that most important part, the agent doesn't stop after finding the error. It fixes the problem by changing the divider value, right? So it is changing the divider value to 1. So this is called self-correction. After fixing the issue, the agent tries again and this time it succeeds. The final result is shown correctly, right? This simple example shows the core idea of agentic AI. The system detects the problem, correct itself, and continues working without any human fixing it manually. Okay. So what you just saw is the basic idea behind the intelligent AI agents. They don't panic when something goes wrong. They detect the issue, fix it, and move forward. This same logic is used in large AI systems, just at beginner scale. Okay, got it? If you have any doubts regarding that code, you can ask me. Okay, so that is the basic uh, agent I have built. So it is checking for the issue and identifying the solution for that issue, and it is applying, and then it is checking the action whether that action is succeeded or not. So this is entire thing is done automatically, so without our interaction. Okay, so this is how the AI agents works in real life. Got it? So guys, if you have any doubts regarding today's session, you can ask in the Q&A session. Okay, so I hope the real world sir simple example is clear. So how agents works behind is this example can demonstrate that. Okay, got it? So if you have any queries, please let me know. So I hope today's section is very clear, right? So we have discussed entirely about theoretical part, how the agentic agents works in behind, right? So if you have any queries regarding that, you can ask in the Q&A, okay? So if you have not understood any topic, please let me know. Yeah, okay. So thank you all for your patience and being interactive in during the session, okay? So have a great weekend. So have a great day, okay? So we will continue on Monday, okay? So thank you everyone. Now you can leave the session, okay? Thank you for your responses and your activeness in the session, okay? Thank you all. Roshni Chaudhary, may I know what is the issue you are talking about? So guys, fill the Google form before 8, okay? So after 8, it will be closing, right? So that's why fill the Google form earlier, okay? Thank you once again. Have a great weekend, okay? We will continue on Monday, okay? Thank you.